Hi everyone, today we're going to deal with the property of logs, and this is when we're multiplying inside of a log. And how will this look like if we want to rewrite this? Okay, so the rule is somewhat confusing because it's not intuitive. So here is the rule. The rule is product property for logs. Okay, this is a product property for logarithms. Now, this doesn't seem intuitive. Okay, so I'm going to come up with a couple of things, and I'll show you guys. So here is the general rule. If I am adding logs, if I say log space, let's say 10 of 3 plus log base 10 of 4. Okay, if I am adding logs on the outside, I am multiplying them on the inside. Okay, this is the rule. When you're adding things, usually you can't combine them if they're not the same type. If I told you 3x squared plus 4x, since these aren't the same type, we can't add them together, right? This is we're done. Okay. But if we have the same type, 3x squared plus 4x squared, see these are the same type, this becomes 7x squared. Right, because they're the same type. I have 7x squared, I have 4x squared, I have 7x squared total. I have 3 second graders and I have 4 second graders, I have 7 second graders together. But for logs, it doesn't act this way. It acts, if I'm adding on the outside, I'm actually multiplying on the inside. Now, why is that true? Now, why does that work? So let's go ahead and look at this using some other numbers. Let's use log base 10 of 100. Okay, let's use this, plus log base 10 of 10, using 10 as an easy number. Now, according to our rule, we end up with having log base 10 of 100 times 10 is 1000. Now, are these equivalent statements? They don't look equivalent, but are they? Now, this takes us back to what logs really are. If you guys remember the slogan before spring break, what do logs solve for? Logs solve for exponents. Logs are actually exponents. The answer to logs are exponents. So 10 to what power exponent is 100? 10, let me write this a different way maybe for us to see. 10 to what power is equal to 100? 10 to what power is equal to 10? So log solve for exponents. Log base 10 of 100 is equal to 2. Circle of logs, 2 to the second power is 100. Log base 10 of 10. 10 to what power is 10? 1. So if I want to rewrite this, log base 10 of 100 is actually 2. That actually number is 2. Plus 10 to what exponent is 10? That's 1. Well, 10 to what exponent is 1000? That is 3. So 10 as log base 10 of 1000. 10 to the third power is 1000. And isn't it true that 2 plus 1 is 3? And that's what happens when we add logs. We add logs, it doesn't combine like a traditional way our problems would. So if I'm adding logs, it turns out to be a multiplying inside problem. Now I'm going to change this up slightly. I'm going to give you guys, what if I give you, for instance, x plus x? We know x plus x is 2x, right? Does that also work with logs? Well, let's try it. If I say log base 10 of 10 plus log base 10 of 10. See how these are exactly the same? If we follow our rule, the rule says this is log base 10 of 100, because 10 times 10 is 100. And see, this is inside the log. Okay, that's inside the log. But if we use algebra and say, hey, these are like terms, we have 2 log base 10 of 10, right? Would this still be the same answer? Well, we said before that this here, what exponent of 10 gives you back to 10? That's 2 times 1. And what exponent of 10 gets you to 100? That's 2. And this is still an equivalent statement. So sure, we can add them like if they were algebra problems, but they have to be exactly identical. Exactly identical. If we look at this problem and we say, well, how do you combine them? If they have the same base, if I'm adding logs on the outside, see, I'm considering this as the outside, we multiply on the inside. We multiply on the inside. And that is a rule that we need to remember because we might have to rewrite a log here or there. If I'm adding logs on the outside, I am multiplying them on the inside. What if I'm adding them on the inside? Does that mean I'm multiplying them on the outside? No. Log base 10 of 2 plus x is not log of 2 plus log of x. This is not true. This is bad. It only goes in one direction. Okay? This is not the same thing. But if I want to write log base 10 of 2x, if I'm multiplying on the inside, we can undo it, and on the outside, we are adding logs. This inside value becomes 2 separate logs by themselves. So the rule is pretty easy by saying if I'm adding on the outside, inside a log means I'm multiplying them together. But I can reverse that. If I'm multiplying on the inside, it means I'm adding on the outside. Now, I'm going to show you, this is a dumb thing, but what if I do that log base 10 of 1000 again? And this is like an easy problem because 10 to what exponent gives you 1000? We know that answer is 3, right? That we know this is equal to 3. Now, if I say this is 10 times 10 times 10, okay? 10 times 10 times 10. Well, if I'm multiplying on the inside, that means I'm adding on the outside. And log base 10 of 10, that's 1 plus 1 plus 1, and they're still equivalent statements. Again, it's just for us to play with this rule of adding is multiplying. Now, why is this true? Why is it that this weird thing of addition becomes multiplication? Why does addition become multiplication? And it really goes back to Algebra 1. If I say 3, let's use 10 because we've been using 10. 10 squared times 10 cubed. If I'm multiplying powers, what am I doing to the exponents? If I'm multiplying powers, what am I doing to the exponents? We are adding exponents. If you remember this rule about adding and multiplying exponents, if I'm multiplying powers, I add the exponents. This is the product of power rules. And that's the idea here. We are multiplying on the inside. It really means adding on the outside because we're just adding exponent, exponent, exponent together. These are all exponents. If I'm multiplying the answer, I am adding the exponents. Look at this using our example. 1000 is 10 to the 1 power times 10 to the 1 power, right? Isn't this just 10 to the 1 plus 1? If I'm multiplying on the outside, I'm really adding on the inside. Wait, if I'm adding on the outside, I'm multiplying on the inside. So this rule of adding and multiplying is actually what we've learned before. But logs specifically deal with exponents. So you can see here, I'm multiplying answers, I'm adding the exponents. So let's look at a big chain here. On the IXL problems, you guys are going to be writing stuff around. So if I give you a problem, let's say log base 3 of 6 plus log base 3 of 5 plus log base 3 of x. Now this is flipping it around. I'm adding on the inside or outside here. Am I adding on the inside or outside? If I'm adding on the outside, this implies I am multiplying on the inside. So this is a way for us to combine logs together. A way for us to combine logs together. Sometimes you can't complete a log. If I give you log of base 8 of 4 plus log base 8 of 2, right, looking at this, you're like, I don't know 4 to what power is, so 8 to what power is 4? 8 to what power is 4? I don't know. And 8 to what power is 2? I don't know. Those aren't easy. But if we combine them, adding on the outside is multiplying on the inside. 4 times 2 is 8. Turns out that's just 1. Now, why would that be 1? Well, turns out our exponents here would be 2 over 3 and 1 over 3. And 2 over 3 plus 1 over 3 is 1. The x values that would have worked, the exponents that would have worked are these answers here. Okay. So let's do something a little bit different. So a couple of logs that we want to make sure we know it for sure already. It's a log with the same base as our question here, log base 3 or 3, that is always equal to 1. Why is that always equal to 1? Circle of logs, 3 to the 1 power is 3. 3 to the 1 power is back to 3. It takes one exponent to bring me back to myself. Here's another log as a reminder. Log base 3 to the 0 power is equal to 1. Anytime your log is 1, the answer to that, what exponent would bring you back to 1, it's always going to be 0. A couple of key notes also is that whenever we see log by itself, log of, let's say, 10, this is always log base 10 of 10. That's what we call a common log. And this is what we discussed before. We have special natural logs. If I write log base e, okay, let's say x, so many variables, Mr. Ko. This is another way of saying natural log. ln is always base e. So if I take log base e of e, would be natural log of e. Whenever you take the natural log of e, that's just equal to 1. Because e to the 1 exponent gives you back to e. These are just some logs that if we haven't seen them before. Okay, so I'm going to give you guys a problem that looks a little weird. Let's write log base b of 3e. Okay? So how can I rewrite this as a sum of logs? Well, if I'm multiplying on the inside, see how this is actually inside? What does it mean that we're doing on the outside? We are adding them. That's what the rule does. If we can simplify, great. If we can't, we can't. If I have multiple letters, log base u of x dot y dot z. If I'm multiplying on the inside, we can rewrite this as log base u of x plus log base u of y plus log base u of z. right. Our one more rule here that we're working on today is, what if I'm dividing logs? Okay, dividing logs. Okay, meaning, what if I write, now here's the problem. When I say dividing logs, it could mean two different things. So let's break this up. On the inside and outside, let's call this outside here, and inside. Okay, if I have a log, let's say a divided by b. See how that happens on the inside? Versus log of a divided by log of b. Okay, these do look different, hopefully, to you. One is the division sign happens inside the log. The other is the division sign happens outside the log. And these are actually two different meanings. They are not the same meaning. And please don't say, Mr. Code, the logs divide out. They do not. Okay, the logs do not divide out. So let's deal with one on the outside first, because we did this before. This is called change of base. And that's why logs can be confusing, because we're really learning a couple new rules of this new language of solving for exponents now. We're not dealing with exponents, we're solving for them. And we have to learn a new way of writing these. So this is change of base, log base b of a. Right? So that's how this changes. If I write log of, let's say 25, divided by log of 5, okay, this can be rewritten as log base 5 of 25. Now, can I simplify? How many 5s do we need to get to 25? What exponent of 5 gives you 25? Circle of logs. 5 to the second power gives you 25. So log solve for exponents, so the exponent here would be 2. That might not have been obvious until I rewrote it. But if I write it with a division on the inside, turns out this is just the opposite of multiplying on the inside. See how I'm multiplying on the inside here? Multiplying on the inside. The opposite of multiplying on the inside, which is multiplication, is adding. When we divide, this is actually just subtraction. Log A minus log B. Log A minus log B. Let's do a couple more of these. If I say log of x plus 3 over x, okay? We're using a common log here. If I'm dividing logs on the inside, I'm just writing it separately, but with a minus. We're taking top minus bottom, the bottom. Not super impossibly hard to do. Let's do one more. What if I'm saying log of e over x squared? Okay. What happened? How can I break this up into two separate logs? E over x squared. Well, this is log, e is on top, and minus log of x squared on the bottom. Okay, log x squared on the bottom. Okay. Seems pretty easy. Seems pretty, I guess pretty basic, I guess. But the problem is being able to remember how to rewrite them and which one works, right? Which one is which. And if we forget that, that's the part. If I'm dividing on the inside, is that subtraction on the outside? If I'm dividing on the outside, is that change of base? And that's kind of where we get kind of stuck sometimes. Okay. All right, so I'm going to mix these all together. And if I write log base 3 times x over y, I want you guys to write this separately as separate logs. log 3. If I'm adding, I'm multiplying. So if I'm multiplying, I'm adding. That's log plus log x, right? That's on top. And I'm subtracting by log y. So Siddharth, you are right, and you probably remember your algebra 2 rule, which is something we're going to cover right now. Let's go the other way. If I say log of x squared plus log of 3 minus log of 6 plus log of y. Okay, I have a couple things going on here. Now, please note that all the positive logs here are going to be on top, and all the negative logs are going to be on the bottom of my fraction. So when we rewrite this as one log, this is one big log with x squared on top times 3 on top times y on top. See, these are all multiplying with the only negative log on the bottom. So these are pretty fairly easy. I'm going to go ahead and change some on your homework to make it a little less work for you guys. I'll change the expected SMART score to 70, okay? So you guys can finish a little faster. But I did add an extra assignment. Okay, and then now we have one last rule when it comes to rewriting these logs, and it's super important for us to be able to rewrite these logs. If I write, now this is the power property. Power property of logs. And this is one of the most important rules that you will learn about logs. The most important, okay, is that if I take the log of an exponent, see how there's an exponent here? This exponent gets moved to the front. I call it brings down the gods. It takes a 2, it comes down, and we're left with log of x. Okay, and this is a basic rule. It's not intuitive, but it really is supposed to be. Okay, let me go ahead and rewrite this for you in a different way. If I write log base 10 of 100, right? 10 to what power is 100? 10 to the 2 power is 100, right? Okay, let's take that as a start because we know what the answer is. What if I write this instead of as 10 squared? Isn't 10 squared the same way of saying 100? 10 squared is the same way. Now, if we use our power property, where does that 2 go? It goes in the front. Logs always bring down the exponent. It brings down the exponent to the front of a log. That becomes 2 log base 10 of 10. What do we say a log of itself is always going to become? 10 to what power is 10? If you ever forget what logs do, just say, what's the exponent? Fine. What's the exponent of 10 to get me back to 10? That is going to be 1. And we're back. And that is always the case. I'm going to go ahead and spin this around, give you guys another problem. If I say log base 3 of 27. 3 to what power is 27? 3 to the third power, isn't that 27? So if I rewrite this 27 as log base 3 of 3 cubed, so many 3's, Mr. Code is confused, so many 3's. But hopefully you notice that this 3 is an exponent. What do logs do to exponents? And it's always this easy case where it takes that exponent and it moves it to the front. It brings down the gods. 3 log base 3 of 3. And we said any log to itself. 3 to what exponent is 3? That is always just going to be 1. Same answer. Logs bring down the exponents. So why is this important for us? Because we'll be using logs later, and we're going to use mainly that tool to help us solve logs. Now, we'll do a simple version of this, one that we do know the answer to. If I write if I write 2 to the x power is equal to 8. Okay. This power rule principle is actually the main rule why why we're learning logs. Because as you can see, this x is in the exponent. And when things are in the exponent, variables are in the exponent, it's actually impossible for us to solve it. We can guess it. We can say 2 to the x power is equal to 2 to the third power, right? Isn't that true? 8 is really 2 cubed. So then we can say, oh, since they have the same base, oh, x has to be 3 then. Or you could guess 2 times 2 times 2. All right. Darn. Is that it? Am I also supposed to just guess? Now, here is where this is all headed for. And this is Algebra 2 skill. If you guys haven't learned it, that's fine. This is on SAT. If I want to solve for it, here's the skill. I put log to both sides. If I do one thing to one side, I'm going to do one thing to both sides. If you see, I'm going to write log to both sides. Okay. What do we say log does to exponents? It took something that I was not able to touch before and moves it to the front. X log of 2 is equal to log of 8. We can divide the log 2 to both sides because that's just some number. Divide log 2 to both sides. X is equal to log of 8 over log of 2. And on your calculator, if you write log 8 divided by log 2, you will get the answer 3, which is what we wanted. But we were now able to do it algebraically. And that's where this power property comes from logs. It's most useful, not because we want to rewrite stuff. That is just a proof to show why it works. But the reason why is we're going to use it to solve for exponents later. Okay. And let's do one more problem as we mix everything together. Here's the problem. If I say, so we want to break up the log. Break up the log. So if I say, what's the log of x squared, y cubed divided by z to the fourth? We're going to break up the logs. We're going to say, hey, multiplying means adding, dividing means subtraction. Log of x squared plus log of y cubed. Because if I'm adding, I'm multiplying, and if I'm dividing, I'm subtracting log z to the fourth. So please take a look. If I'm dividing, if I'm multiplying. Now the next rule is I'm going to take the exponents and move the exponents to the front. Power rule says I can move down the exponents. 2 log of x plus 3 log of y minus 4 log of z. Okay, and that's it. That's what you guys are going to practice. We'll put this in more into application later, and we'll see how we can solve for actual numbers in this situation when I see you guys next time.